Good afternoon, everybody. It's Saturday, my friends, and we're gonna finally jump back on in to some more coding here, or trying to learn how to do some Java game dev here. If I can manage it, perhaps we'll see. We'll see how it goes. But welcome on in, everybody. Welcome, welcome, welcome. Hope everyone is doing well. Hope you're all healthy, happy, and kicking butt, taking names, and doing what you gotta do. Hey, my name's Steve. Welcome on in. So I had left a note for myself as to where we left off here. So it looks like clean up message there. So let's go scroll down to that. See where we're at here. If I can find something. How's Linux gaming treating me? Pretty good. Pretty good all around. I haven't run into too many issues. Like occasionally, I'll run into a game that doesn't that needs a little extra work on it. And sometimes it's kind of weird because some of the games that have native Linux versions, like that you can get on, say, GOG and whatnot. Shadowrun Returns being the most recent one. The Linux version just doesn't launch. It's missing libraries. But if you run the Windows version, it runs fine in Proton. So it's been really good. So it's been odd from that perspective, but also things have just kind of worked. So that's been pretty good all around. And yeah, not too much craziness. I mean, there's some visual stuff here and there that's kind of off with some games, but I think that's more a function of just using an AMD card versus being on NVIDIA. So that might be just that too. Because I have the latest drivers and everything. So, you know. Is this... I think I'm going too far here. Yeah, completing the change. Oh, yeah, here it is. So clean up. So then, yeah, I think we're at the point where we just need to start completing all these changes here, like finish the plumbing, which is awesome, but at the same time, I feel like we're gonna have some problems here. There's gonna be some things I'm gonna have to do, almost definitely, that I've got wrong or that aren't wired up properly, and all that stuff. So we'll have to see what we get here. Oh, okay. So the allocator here, I think we have to still do the cleanup methods, if I'm not mistaken. All right. So where are we at here? Yeah, cleanup, free descriptor set. Okay, cool. So we'll do that. Let's clean up info map clear and the list call cleanup on all the things. So what are they doing here? We're in the map. And pool lists. All right. So and then pool lists for each. What are they doing? Clean up. Okay. Go, and then what else? That's it. There's a free descriptor set I get. So they're freeing it so they're going to a particular ID. Just setting it to null. Huh? Okay. Okay. Oh, if it equals null, return. I see. Otherwise, it's freeing it up. And then what? Info. Pool position. List that size. Okay. Free descriptor set. That's okay. Well, that does technically free it up, but then it doesn't remove it from the descriptor set info map. Which is interesting. Yeah, like, shouldn't we remove that from the map too? That being said, there's also no usages of this method, so they're not even actually calling this method. So I assume this is for later or something, but descriptor set info map is how are we, so we're doing that there. What is the ID that we're putting in there? ID is passed in. Okay. So that's going to call the free descriptor set. Yeah. But it doesn't actually remove the reference to it, so I feel like this is an incomplete method. So I guess I'll take the extra step and do it properly, I guess. Even though it's still not being called, so it's probably not going to do anything now. Nice. String ID. Okay. Descriptor set info map get ID. Descriptor set info. ID else no. Which I guess is the same as just calling get. But sure. Yeah, I mean that is the same as just calling get. So let's just do if info is null. Okay, otherwise is greater or equal to descriptor pool list size. All right. Okay. Otherwise, descriptor pool info. Okay, descriptor pool info. Descriptor pool list. Okay. Where are we getting that from? The list get full position. Okay. Right. Set info pool position. Okay. And then we're going over the descriptor sets in the set info. Okay. For each pool info descriptor pool free descriptor set. Okay. Nice. And then get descriptors. So get the ID. What is the descriptor set? Descriptor set ID. The ID here. Oh, I guess I never put a... Wait, yeah, it's a long, right? Okay. So I never put a get ID on here. Okay, and then I would imagine we would do so we freed up the descriptor set there for that ID. Info. I don't know why they're not removing it from... Well, I guess it is saying free descriptor set, not the info. So maybe that's what it's supposed to do. That's weird. Alright, then we have get descriptor set for ID and position. Public synchronized descriptor set, get descriptor set. Okay. Public synchronized. It's ID and position. we're saying descriptor set info map get ID. Okay. Descriptor set. We're looking at the info map, right? And we're returning descriptor sets position. Set info map get ID set lists. Get position. All right. Return results. So we're not doing any bounds checking on that at all, which is a bit strange. I guess it's not that strange, but still, well, it is what it is. Right now, I'm not going to worry about it. And then I have an override for it that doesn't take the position, just sets it to 0. Okay. Sure. Looks like potentially everything in the allocator. Alright, so what do we have next? We have to just go through and wire it up to the rest of the system. Pipeline class needs to be updated to take the descriptor set layouts into consideration. Pipeline build info, be able to store an array of descriptor set layouts. Okay. So I might have already done this. We have a private descriptor set layout, descriptor set layouts. All right, so we're here, pipeline build info. Don't have a pipeline build info at all. Okay. Let's look at the comparison here. Huh. Oh, is it the pipeline create info? No. Pipeline. I don't know where this class came from. Is this something that they refactored? And now it's all completely changed, and now I don't know what I'm looking at anymore. What does pipeline build info have in it? Shader modules. Color format. What is this used by? It's used by scene render and by pipeline. What's brought into pipeline in the constructor? So scene render, shader modules. So it takes an array of shader modules. Do I have something similar? Something common, maybe? A shader compiler. This is going to be a real... this is going to be the annoyance here, is that they completely refactored and changed their book while I was already up to chapter 7. So now and because their book, every chapter builds on the previous one, all the earlier chapters change, and now I'm all completely out of whack here, which is a real pain in the butt. I've got Vulkan shader program. I think this has got the shader modules in it. Okay. So what are they doing with build info? Pipeline vertex input state create info. What the hell is in this? Oh, this is a... Okay. That's a Vulcan class. Or an LWJGL wrapper around Vulcan. I really don't want to go all the way back to the beginning and have to start over again. Because I have so much stuff written here. This is frustrating. This is really frustrating. Like, I wish that if, you know, it's fine to update the book and update the examples and stuff. But, like, you know, throw me a bone here. Like, let me know what you actually changed. You know, like, this is how we used to do it, and this is how we're doing it now. The only reference to pipeline build info is in create pipeline, which is in the scene render. Oh man, this is infinitely frustrating. Everything changed under covers on me. Where did the... This is... very, very frustrating. So where did I... See, the other problem is I don't know what chapter they introduced that. It wasn't chapter 7. Chapter 7 they have... Let's do something here. Let's go... Share files. And we'll do chapter 7. Okay, do this one first. Chapter 6. Come on, just open everything. Here it is. Chapter 6. Chapter 7. Okay, so it existed in chapter 6. So all right, it was introduced in chapter 5. Go back to chapter 5 then. Chain stuff, there's the Q stuff, dynamic rendering. We use Vulkan dynamic rendering versus traditional approach based on render passes. So this is the big change that they made. Instead of doing the frame buffers, which I have all set up, they're doing dynamic rendering. Dynamic render provides a simpler API with which we just refer to the attachments, the images that we wanted to render, versus having to specify them up front through render passes and frame buffers. The result is fewer code and reduced setup steps. Great, that would have been useful earlier. Dynamic render provides more flexibility, and we can change the target attachments at runtime without recreating the associated elements, render passes, and frame buffers. For certain tasks, it's a little bit more explicit than a traditional approach. For example, with render passes, you get some implicit image transitions. Dynamic render requires us to explicitly define layout transitions and synchronization, which requires a little bit more of code, but is not so dramatic. Where everything is explicit, you don't have to guess what automatic transition or locking is applied. Okay. Invite, create attachments, render area, render method, image barrier, render. Image barriers are a way to properly synchronize across or synchronize access to images in Vulkan, either for read or write operations. Manage image layout transitions. A barrier is set. Command buffer. Control the execution of next commands. In order to execute them, the conditions set by the barrier need to be fulfilled. This is why it's called a barrier. It blocks next commands to be processed. In order to properly use swap chain images, we need to transition to the proper layout. We need to transition from layout undefined to layout color attachment optimal for rendering, and then to layout before presentation. We'll achieve this with memory barriers and the main purpose of setting them in the render method. Okay, image memory barrier to colic. Command buffer. Caches, having multiple places where data can reside can lead to inconsistencies. Therefore, we need to properly control how we access it in Vulkan. When we say memory is available, data is ready in the main cache. Data found reaches these low caches, say it's visible. In order to control availability and visibility, we use the combination of stage and access masks. Stage masks control which point in the pipeline. Okay. Okay, device, dynamic rendering and synchronization. We need to enable them as features when creating our logical device. Control if compressed textures are enabled or not. If 64-bit floats are supported. Okay. Oh man. See, what's the worst part of this is probably is a lot less code and probably is the better way. But now I've got to go and basically remove all the code that I've got around this and try to bring it back down to this point so that we can then go forward again. This is the worst. This is the absolute worst. And the reason this is so much more terrible is that this guy writes code terribly. Like, the code in this book is the worst code I've seen in a long time, as far as Java code is concerned. So along the way, I'm trying to fix it so it actually, like, makes sense. You know, like, so that I can make sense of the code myself. Because a lot of his variables aren't named well and all kinds of nonsense. He's doing C-style stuff when he should be doing Java-style stuff. And now I gotta unwind all that crap and try to pull all this stuff in, which is disrupting my calm. How will I do this? How will I do this? That is the real question. So The pipeline cache. So we can look at the pipeline. Okay, we just gotta do it. Oh, we just gotta do it one. Oh, one step at a time here. So we know stuff around the pipeline exchange. So if I take so if I look at the pipeline cache and compare it to mine, let's see what's different here. Number one. And then we know I need all of pipeline build info. I don't have it. And we'll have to look at pipeline to see. So pipeline build info is only referred to by pipeline. So it's at least isolated somewhat. So I can look at pipeline build info, pipeline cache. I'll probably need to look at the shader module class and the shader compiler again to see if they're vastly different from what I have. Buffer I'm going to assume is probably okay. We'll see once I get into it. Alright. First things first, we know we don't have a pipeline build info. So we make a pipeline build info based on chapter 8 here. And roll with it. It's going to be, stuff is going to be broken, but that's fine. Text input state create info. I don't know why they have to keep that around in the constructor, but they do. It's just a little bit weird. So this is my bugbear here, is they do shit like this, and then you look at it and you're like, what the fuck is VI? Oh, it's vertex input state create info. Oh, how was I supposed to figure that shit out? You know, if I'm seeing a call to get VI, like what the frick am I looking at? I hate that so much. It's just like, I'm sorry, but when you're writing a book that the people who don't know or trying to learn from your book, you can't be doing shit like this, or shit like this, or shit like this. Like, I'm sorry, it means you're gonna have to type things out, but you're gonna have to type things out. And also put some goddamn comments around. I mean, hell, we live in the age of AI. You can have AI generate your damn comments. I don't care, as long as it's something. And these goddamn arrays. It's freaking array happy all the time. Like, that pisses me off more than anything else. It's like, you go around to any Java developer, and most of them barely, if ever, use an array for anything. We'll just use an array list because it's the best of both worlds. And now with stream syntax and all that stuff, like, there's no reason not to use it. And yet here they are, let's just copy it from a C book. Just drives me up a friggin' wall. And what's even funnier about something like this is that you can see in various places in their code here, when they want to use stream operators, they'll do an array as stream wrapper around an array list to get themselves an array list so they can do stream operators. It's like you haven't just make it a damn just making a damn array list from the beginning, and you don't have to do that nonsense. Really annoying. Alright, let's make this huge change under the covers here if we can. It's going to be a pain in the ass one way or the other. So I want color format, shader modules, depth format, descriptor set layouts, constant ranges. The other part of this that bothers me is that none of this is helping me actually learn what I'm doing. Like I wish, and I don't think that's necessarily the author of the book's problem. I think Vulkan is just so poorly designed that it defies learning. Right? It's like one of those things where, you know, it was made so, it's one of those things where someone was really looking for some what's the terminology I'm looking for? Someone was really looking for some job security, and they didn't care who had to use it later. Oh, you want to learn this for the first time? Good freaking luck. And I'm just here hoping that if I code enough of it and I break stuff and I fix it enough, I might actually understand what I'm doing, but that's a big reach right now. Alright, so this is pipeline build info. So where's my pipeline cache and stuff? Okay. Pipeline cache and everything, so let's go under here. You know what? I'm gonna just make a pipeline package. And that'll help me realize what's old and what's new, and I can move the old over to the new once I get there. So pipeline color format shader modules. Do I have that? I have that as a record under here. Seems like they've actually pulled it out. Which, yeah, I should just do that. What does their shader module class look like? Yeah, they pulled it out and made it an actual class. Go figure. They have a shader module class. Let's do that. Let's pull that out. Handle shader stage. So what do I have? Same thing. Int shader stage long handle. Okay. Yeah, let's go do that down here. Make it a proper class. Shader stage. Handle. What is this? The hell is this place? Oh god, they threw everything into one class that doesn't make any freaking sense. Great. That's fantastic. What are they using for it? Create shader module. I hate this so much. Yeah, let's pass an entire freaking class in and all we need is one little thing from it. Yeah, that makes a ton of sense. Jackasses. I hate that so much. Yeah, we'll just put all this crap into one bucket and we'll just throw the entire bucket in there. Because that makes understanding what's going on so much easier. Okay, so that's just a device. It's actually the VK device, so it's probably the physical device. I'm gonna guess. VK device, yeah, probably the physical device. In my parlance. So shader module. Files read all bytes. Module contents. Create shader module. Shader stage. New file. Module, destroy. Okay. Which I have some of this already. It's just they've moved it over to here, which probably makes more sense, I guess. Wait, shader module, isn't that just shader program in my thing here? Oh yeah, that's just shader program for me. List of shader modules. Shader modules add. Do they put these somewhere? Shader module. Shader modules. Yeah, I mean, they just get, okay. Just have the, okay. Sure. This is basically what I already have. So really, I just need the this takes a list of shader module data, which has the SPV file in it. So so what else did they have in their shader module? Handle shader stage, that's it. And a cleanup. Which this has, this just does a cleanup based on the handle here. I mean, I guess it makes more sense to have that stuff, have the cleanup in the shader module itself, because you might only want to clean, like, you might want to swap shaders in and out. Let me see. Module. Start doing that though, so default be a lot nicer on some of these things. So create. So what I really need then. Shader modules. So shader module really could just be a record. If we want to, I could put a cleanup in there. So you can clean up an individual shader. I don't really need that right now, though. I mean, does that help my cleanup routine at all if I do that? Not really. Yeah. Doesn't really buy anything. Okay. Now I'm going to keep Vulkan shader program. But that just means I come up to here, and I'm just going to say this is shader module. That's fine. Alright, what else? VK pipeline vertex input state create info. Format. Scripture set layouts. Push constant ranges. What was it? Push constant range. I don't know what push constant range is. It's just a record. Push constant range, stage offset size. Where is that? Under VK like everything else. Okay. Push constant range. Okay, so push constant range, stage offset size. Stage offset size. Okay. And this takes a list of shader modules. Create info in the color format. What else was it? Oh, for Christ's sake. I hate that. Color format. So share modules, color format. Okay. So it takes those. And then it sets the depth format to VK format undefined. So I'm just going to do that up here. All right, got some getters. Okay, get color format, get depth format, set depth format, set descriptor, set layouts, and set push constant ranges. Okay, so the setters and getters are depth format, descriptor, set, and push constant. Okay. So format. So these are getters and setters, right? Descriptors, set layout, push constant ranges, depth format. Yep, and then the pure getters are color format, shader modules, and vertex thing. Okay. These other three. Got it. So that's the pipeline build info, right? All right, who uses you? More importantly, who builds you? Scene render does. Okay. Okay, and then pipeline just takes it in as a parameter. Shader modules. Push constant ranges, descriptor set layouts. See, this one's actually used for a couple different things. So that's actually good. Okay, so pipeline. Let's look at our pipeline here. Okay, so I had pipeline create info, which had the Vulkan shader program, depth attachment, push constant size. Had some of that stuff. Base vertex input state info. See, they had base vertex input state info. One inheritor. Who inherits this? Vertex buffer structure. Did I do this in particular? I don't think so. I think this was something that they did. So So what are they doing in their pipeline now? Device. Get shader modules. Pipeline shader stage create info. Info buffer. Shader stages. Shader modules. Get shader modules. So okay. Right, so we got the shader stages. Right, or what they're calling yeah, shader stages. Got it. Assembly state, create info. Primitive topology, triangle lists. Viewport state, create info. Viewport state, create info. One, rasterization state, create info. 1.0 if. Okay. So multi-sample state create info. Okay, sample count 1 bit. Alright, and then depth stencil. So what are we doing here? Depth test enable true, right enable. So we're not even looking to see if there's a depth attachment. We're just assuming that there is one. I'm guessing. Oh, we're just saying if the depth format does not equal VK format undefined. So I probably did a has depth attachment just because that's kind of silly to do that check there. So what was the, let me look at create info here. No, okay, that was just a booleaner. So I'm going to do Do as depth format turn does not equal VK. Okay, so there we go. So I can say info has depth format. Here we're doing stencil state create info. True, true, compare op less than or equal. False, false. Okay. There you go. So we're going to change all these to $ default for things, but keep this for now. We'll do it piecemeal for now. Then there's color blend info, right? Wait, there's dynamic state create info. Okay, so that must be, no, okay, dynamic state create info, I have that here. So do I not need a color blend info? There's a color blend state. Color blend state create info. Oh, okay, so that's, so it is there. It just was down further. All right. So dynamic state create info. Dynamic state viewport, dynamic state scissor. Okay, so I have that. And then constant range buffer. Constant range buffer. Push constant ranges. Info get push constant ranges. Oh, this one, the color blends. Well, we'll come back to it. Push constant size is greater than 0, then create constant range buffer. Push constant ranges if so number of push constant ranges does not equal 0, then the length otherwise 0. Okay. Push constant ranges. Push constant ranges. So constant ranges. So then it would be in here. Set layouts. Right. And that way, if they're not set, they're not set. They're empty, I should say. So we're saying essentially here, push constants is greater than 0. So if info heat when it pops up this nonsense there. Get if not empty, then create constant range buffer. Stage flags, offset size. And this should take now push constant range. Street size, so this would be stage flags is vertex. No, stage offset and size. Okay, stage flags, offset size. Okay. Alright, so excuse me. Okay.
Welcome back to Citadel Station. We hope your somnolent healing stage went well. Today is the 6th day of November, 072. You are currently in the suites located on the first level. Level 2 contains the research laboratory. 3 houses the Department of Maintenance, and the storage cells are on level 4. The flight deck is on level 5. Level 6 holds crew facilities.
I'm gonna push constants.
Systems engineering. Level 8 houses the Department of Security.
Oh, for each one, set the thing. Okay. So call like with the number of push constants. I see. Okay. So yeah, this one's just doing one off the bat. So this would be list and then we'll just do actually I can do for each. I can do wait. Yeah, call up and then set them. Yeah, okay. So, okay, push constant range. Ranges. Stack, and then for each constant range, oops. Menu. Alright. Okay. So that should work. Constant range buffer. That gives us the buffer back. And that's good. So then pipeline layouts. Okay, now it's doing descriptor set layout. So instead of pipeline layout. So let's do that. Descriptor set layouts. And then it is set layouts length. Layouts it's mallocing, and then putting them into pointer buffer. Okay. So let's comment that out for a minute. Say if if it's not empty, then long buffer. Descriptor set layouts buffer. Get percent layouts dot size. Layouts dot size, and then VK descriptor layouts. Isn't there like a malloc long where I can just give it the or I could probably just do it on the buffer. Descriptor. Surprised they don't give you a way to just like put a whole bunch of them. Oh, they do. They give you an array. Yeah, put index long source. So 0. And then it's just, what are they doing? set layouts. Yeah. So it would be get descriptor set layouts. Dot stream map be descriptor set layout get ID. All right, that's what they're doing. Yeah. So collect I wish there was like an array collector, but I don't think there is, so it's going to have to be arrays new. No. How do you do that? I'm drawing a blank here. Java stream collects to array. Oh, there is a to array. Gotcha. Okay. This would be just long. You. Not resolve method put into a. I guess I gotta cast it. That's kind of weird. I would have to cast it though. Wait a minute. Oh, there is a put long array. Just buffer. Okay. But it still says it can't resolve that method. I feel like did I do something wrong here? Oh, they're doing string array. Okay. Hmm. Still not happy about it, but I guess I can just do this long. IDs. All right, and then IDs here. So it's going to tell me it can't find that. Put long. How do I get this to go to a native array? I mean, I know there's an Apache Commons thing that'll change it to a native array for me. But I would think by now we'd have something in JVM to do it, because apparently the auto boxing is not working in this particular case. Because normally auto boxing would say, oh yeah, this is fine. How do you go to native? Trim string new. So that's good, but how do you go to native? Java stream to array native. Feeling they're not going to give me the example I'm looking for. Well, here's a native array. Convert stream to array. Map integer int value. Oh, I see. They're doing map to. Map to int. You could do that. Wait. To array. So do. See, I don't need the map because it takes a regular long, right? So should I just be able to do to array here and have it bring me back? Provided objects. Get ID returns a regular long. So I do map to long. Returns a long string consisting of results of applying a given function to the elements of this stream. Okay. That works. Sure. Alright. So that gives me the descriptor set layout buffer, I hope. Which is this, which we'll use somewhere along the way here. Color blend attachment state. Color blend state info up here, okay. So number color attachments, color mask. So it's 1. Let me see. So color blend attachment buffer. Number of color attachments. Which is just 1 here. Just when I'm passing it, right? No. Color attachments. Color right mask. Okay. Other color attachments. Color right mask and blend enable. Okay. Color mask here, which is RGBA. RGBA, blend enable false. Okay. And then what? Clock stack, default blend, attribute state. Okay. This is create info. Or blend state create info. Yep. Okay, so that should be now returning correct stuff. Okay, then we got create pipeline info. Create info. Okay, what did I have here? Color formats. Which color formats use that? Let's see. For render create info. Okay, color formats. Do I have that here? Maybe that was pipeline layout info? No, I don't think so. I think this is something else. The format. Okay. And create info. Depth stencil state create info. Alright, so this goes hand in hand with the depth stencil. Am I sure I haven't done that? I guess not. Okay. I'm not sure why you wouldn't do both of those together. Does this rely on something else? It just takes color formats, which is already brought in. So why wouldn't you just do these both together? Since it's tied to depth stencil not being null. Right, like we're going through all this. Oh, okay, no, we're creating it anyway. We're just saying if that's not null, then add the depth attachment format. Okay. Never mind. Never mind. Color formats put, get color format. VK pipeline rendering, create info. All right, so let's go into here. What are we doing? VK pipeline rendering, create info. Create rendering info. And then int buffer, color formats. Actually, I don't even need to do that. I can just do that inside there, right? Get color format. So I need the color format, which is an int, and the depth format, which is an int. Actually, I don't even need this part because I'll just do this part myself. So really just need the, well, I could say, no, I'll just pull it out. I'll just do this part in there. So I just need the color format then. Int color format. So we're just doing buffer format buffer stack the alloc int 1 format buffer to put color format. VK pipeline rendering create info. Info. Clock stack. Okay. Type default. And color attachment count 1. Color attachment formats. Color format buffer. Is that it? Yep, that's it. All right. So back here, and then we do color by rendering. What was it? VK pipeline rendering create info. Okay, rendering create info. Directory info, stack, and then info dot get color format. Okay, and then if equal null, depth stencil is not equal null. Depth attachment format is info get depth format. Okay. Okay, and then there's pipeline layout create info. Oof. Pipeline layout create info. So what are we doing there? So that's probably the create pipeline info I have here. No, here's the pipeline layout info. Here we go. This one. Pipeline layout info. Okay, and create pipeline layout, blah, 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 and then we're doing create info. And create pipeline info. So VK graphics pipeline create info buffer. So we're doing the callec there. So they're doing the actual callec 1 stack. Info callec. Oh yeah, that's fine. Yeah. It's return buffer. Render pass is VK null handle. Okay. So we're actually setting render pass to VK null handle. So VK null handle is a change. P stages is shader stages. Vertex input state. Build info. Okay, so vertex input state is going to be info get vertex input state. So this will be long vertex input state info. What does this need? Vertex input state create info. Vertex input state create. That's what it is. Vertex input state info. Assembly state create info. Viewport state create info. Rasterization state create info. Sample state. Dynamic state. Color blend info. Color blend state. Blend info. Okay. Layout is VK pipeline layout. Okay, so that comes from the pipeline layout, which I think we've got. And then we're not passing render pass in, although I'm going to pass render pass in. I'm just going to make sure it's set to null. Type stencil, create info. Stencil state, if it's not null. Stencil state. We're also doing p next render create info. What is this? VK pipeline rendering create info. So this is rendering create info, and that goes where? P next. Okay. Graphics pipelines. Pipeline cache, create info, okay. Get, okay. So that comes back that way. So we have to do the set render pass. To null here. And then it's rendering create info, so that would be pipeline rendering create info. And then the vertex info, vertex input state info. Let's state create info. So that is this. There we go. Okay. So some of that is changed. And forward renderer. Forward renderer needs pipeline build info created. Although I have to see where they do that. This is in scene render. So I don't even know if they're doing forward rendering anymore because they're doing everything differently. So I might have to pick all that apart too. Okay. So build info. They do in create pipeline. So is there any forward render in here anymore? I get the feeling there isn't. Doesn't look like it. So that is all changed around too. Well, we're going to have to do it if we want to stay in line with what's going on in the book here, but okay. We're partially there at least. This actually, so the forward renderer does the shaders and stuff too, but it's also creating the swap chain render pass, which I don't know if they're doing that same thing. Kind of. Yeah, see, they've got like their resize and stuff in here in the scene render. And all that, and I don't know. Loading all their materials here. Create share modules. Create pipeline. I don't know if I like that. I mean, something has to pull everything together, certainly, but and it's even more confusingly to have a render class that calls scene render, which is certainly not confusing at all. This is really discouraging. I mean, This is really, really discouraging. I get that Vulcan is involved and more complicated than it ever really deserves to be, but this is just... This is just... It's just driving me a little bit batty here. Because it feels like I can't, like... By comparison, OpenGL is a freaking breeze, right? And I feel like this doesn't deserve to be as complicated as it is. Given that there's something out there that's been out there forever that isn't as complicated, yet can still hold its own. So I don't know. This just bothers me more than just a little bit. Like, I wish... I don't know. It's hard to... It's hard to see what the final result is going to be. Because none of this crap makes any sense intrinsically. It just doesn't make any intrinsic sense. It's just kind of a whole lot of slop you got to do. It's a lot of boilerplate just to get anything on the screen, like just to make any kind of progress. And half the time you're like, do I need this boilerplate? What is this supposed to look like? How's this going to change later? And then it's just really... It doesn't surprise me that the amount of time it takes to develop a game anymore takes so long, right? Because you're dealing with shitty libraries. And this is the shittiest of the libraries. Like, it's not designed well at all. And I'm not talking LWJGL, although that might be playing some part in it. I'm talking Vulkan in general. Like, it's probably the shittiest library to try to deal with. And it's the big problem there is it's trying to be everything to everyone instead of just being what you need. Like, it's like it's being repurposed to be used as for gaming. Because it's the only modern thing out there. And I feel like so much of this stuff could just be completely thrown away if you just know what your use case is ahead of time. Right? It's like they made this thing that they don't know what you're going to use it for, so they abstracted everything so poorly that it does nothing well, but does everything. When they could have just had like a separate libraries. It's like, here, you want to play, you want to make games, here you go, just use this makes more sense for games. You know. And it's just it's frustrating to work with because you can't, nothing is explained well, right? I don't know. I don't know. I want to make more progress here, but I'm so frustrated at this point that I'm like on the verge of giving up. I don't want to give up. I want to keep going, but it's this is just annoying me in so many ways here. Like I wish there was like small pieces that you could take and just like, all right, I did this small little piece and now I can test it and I can see things happen. Right? Like with the OpenGL stuff, you could take small pieces of it. It was like, I'm just going to do this small little piece and test it. And okay, I see something that works. Right? And this is like, there is no small pieces. It's all just, oh, you want to do this one little thing? Yeah, here's the 9,000 lines of code you got to write before you can even attempt to do that one little thing. I mean, I'll point out yet again, all I'm trying to do right now is load up a model, a 3D model, and have it spin. That's it. And I'm having to do all like this absolute insanity just to make that happen. And it's absolutely crazy. And I'm, it's bad enough that you have that mountain of crap you have to shovel, but then I'm fighting, like there's only one book out there that I found that talks about what I need to talk about, that tries to describe what's going on. And I'm fighting the bad code in there. the unhelp, like you have a book that has code that is not documented. It's got terrible variable naming. It doesn't explain anything. It has very little comments. Like it's just the worst of the worst. And yet it's the only thing I have to go on if I want to try to learn this stuff. All right, if I what am I trying to do? I mean, I would love to go through and refactor this. I mean, this is my code here. I would love to go through and refactor it. But I don't know what to refactor it to. I don't know what the final picture looks like. And what's the... Because they don't have a forward render anymore in their stuff. Think. How do I fight this? I'm still coming out understanding what's going on. I really do feel like I'm at an impasse here. Let's see. Let's see. And the worst part of it, I feel like I need to. I feel like I need to go back to the revamped chapter 5 and try to pull everything out of there. Try to convert all my stuff over to whatever they're doing in there. Although it's not really helping me any, because then there's gonna be a lot of stuff just floating around that I'll need. So I mean, looking at their chapter 8 and then just trying to figure out the differences is probably more useful. Where's their scene render used here? Render. Load materials. Transition textures. Like for fence. Because I would have to go back and do. Hey, Outlaw, welcome on in. Because the problem is I'd have to go back and do. Like, I mean, it looks to me like the queues and fences and stuff and command buffers are probably the same. It's just they changed basically chapter 5 forward. Freaking burning my ass here. I don't know where to even start. That's my problem. I think, I mean, I'm gonna have to just do like a brute force change here. Because I also don't like the way they've named stuff. Not that I like forward render any better than scene render, but man. Been playing Rogue Prince of Persia and got super bored to leave it. Yeah. Yeah, I've heard of that. It's I haven't tried that game yet. See what it was like. I've been okay. Okay. It's been I don't know. don't know. It's physically I'm okay. It's just been kind of not my usual chipper self. I guess. I guess is what it was been this week. Um, feeling kind of defeated, I guess. Um, that's probably the best way to describe it. And not for any particular reason either. It just feels just feel that way right now. You know, try as I might to not read the news and stuff. Sometimes you just can't help but read it. And I don't know. Maybe it's a combination of that and just other things where it's just like I'm just at that point where I'm just like tired. just mentally tired. Mentally worn out. And I'm just what's even what's even annoying me more is I'm trying to learn this stuff and it's not clicking with me right now. You know, like when I learn stuff I need to be able to do it, but I also need like small pieces to be able to do, and it's just right now this thing is annoyingly large and not making any sense. Yeah. Yeah, it's a little bit of that. A little bit of that. I don't know. I don't know. I feel like at work too. I feel like I'm fighting against the fire hose of idiocy. Sometimes, you know, not my colleagues, but the uppity ups in the company just don't seem to understand technology, or at least don't seem to understand how cyclical technology is, and don't understand when a bubble is in the process. You know. So, I don't know. So I've been kind of fighting that too, a little bit. I mean, the AI stuff is impressive, certainly, but the amount that they are trying to force it into existing code without really any thought put into whether or not it's actually worth doing it that way, and whether or not it's actually helping customers is just kind of working on my last nerve. um, it's just a thing right now. Like you try to fight against enshittification as much as you can, but invariably you lose to it. I've never seen anyone actually win against it. I don't know. I don't know where to start here. If I keep... So I got forward render. They have scene render. Is there really that much of a difference? I mean, there probably is. But... Where's their... So they've got create pipeline. Right, and this is their scene render. They got create pipeline. So what they got here? Color. So clear value color, clear value depth, create depth attachments, create render info. So I got much the same stuff. So we got pipeline create info here. So they've got just create pipeline. Which is basically this. Right, so pipeline create info. So I should be able to just do what's in here. Intense music, yeah. What is this? What is this from? Super Metroid. Relics of the Chozo. So. Create pipeline. So I can do that. I can just make a private pipeline, create pipeline. And then we need the pipeline cache. Okay. All right, so then in here we'll do vertex buffer structure. Okay. What is that? Some other class? Position components. Oh, this is basically just... It's basically just to create a pipeline vertex input state, create info. Alright. Pipeline vertex input state, create info. Okay, so, So it's freeing up all of that. I mean, this is a utility. All right, so utilities. So new Java class. Vertex. Vertex buffer util. Do they need any state for this? These are all static. They're just throwing this away, right? Yeah, they're just doing a cleanup on it. And then throwing it away. Okay. Yeah, why wouldn't you just make this a static utility then? Like, I swear to God, whoever wrote this shit they just copied it from C and just said, whatever. Without even putting any thought into, like, how would you actually do this in Java? How would an actual Java developer do this? Not this way, that's for damn sure. Alright, so text buffer util. Alright, so this is, I'm just going to make this just a static class, basically. So private. Alright. And then we want private static final text coordinate components. So this is going to be texture. Coordinate components to static final int number of attributes position components. Alright, so we got that. So then the rest of the stuff we just put inside a static function. Oh, well, see, they're calling. Why are they calling free on that? Isn't the whole point of this to get this back? Because that means you're just gonna free up all the memory for this, and then you're gonna just start using it? Like, what the hell? Yeah, you're passing it into here, into pipeline build info. And then after you've passed it in here, and you get a new pipeline back, then you're going to actually delete this reference. So now it's just, you're going to free up all the space for it, but now it's just unusable. I don't. Because that, what does VI, what's it used for in here? I know it's used for something in here. Shader modules, set layouts, color format. Is it not used right? Oh yeah, it is for down here. Vertex input state. So after you do that, after you create the pipeline, you're saying the pipeline here, this is no longer going to be in memory, so how does that work? That seems like a problem to me. That seems like a really big freaking problem. I mean, I guess that's only needed for the creation, and then it's not needed again. That doesn't seem right, though. I don't. I mean, obviously this is working, so I guess it isn't needed again. But I don't. I don't get that. I don't understand that. So in here, because it seems to me like you can, because then they're freeing these up too, which I guess at that point, if you're freeing those up, then you might as well free this up because it's not going to be pointing to anything useful. I guess. So that's why they made it a regular class instead of a utility, because they need these to hang around long enough to... This whole thing is a giant... I don't even know. I feel like calling it a giant pile of shit is being too kind to it. For structure. attributes. Um, the only thing I can do is pass back either an intermediate object or an object array, and then have cleanup in here. Just take the object array in and call free on everything. I think it'd be better just to have I can just return a record, I guess. This stuff in it, and put cleanup on the record. That might be better. I mean, it'd be a little bit more self-explanatory, at least. Ah. All right. I gotta take a bio break. I will be right back, friends. Enjoy the music, if you please. Okay, I am back. With a peppermint. Let me see. So what can I do with this? I think I know what I'm going to do. It's not going to be the greatest thing in the world, but it'll work. It's not going to be the greatest thing in the world, but it'll work. Let's do... Um... What do I call it? I guess, components, I guess. It'll be vertex input attribute description buffer. And PK vertex input binding. Description buffer. Bindings. And pipeline vertex input state create info. Line. Vertex input state create info. Info. Okay. And then we're doing buffer and what are you doing here? Okay. They couldn't have just said 0 and then 1? Like, what the hell? This is a constructor, you're not gonna... You're setting it to 0 every time. I don't know. You can see this is a part where you can tell that they were copying it from something else. And most likely a C program they were copying it from. Because stuff like this doesn't make any sense. It's like you create a variable called I. You set it to 0. You're using the variable I here, and the variable I here. And then down here, you're incrementing I by 1. So I is 1. I is 1. Then it's never used again. So why didn't you just make this 0, 0, 1, 1? Right? It's like you can clearly see that they're just copying it from like a C program or something. Because you see something like this and you think they're calling this in a loop or something, but it's a constructor, so even if you call this constructor in a loop, you're going to set I to 0 every time you come in. Oh, what the hell, man? I swear to God, it's like they found a way to write this that would just specifically make me lose my freaking mind. That's the only explanation for it. Because no sane person does this. Right? They do it just to troll. I feel like this is just one big, long-form troll. It has to be. Certainly not improving, certainly not giving me confidence in what I'm doing. That at the end of this I will have done something correctly. All right, so input attribute description. Let's get this part done first. So we got vertex vk buffer. Number of attributes. Okay. And then bindings. Just one. It's this one. VK pipeline vertex input. Create info. Info. Okay. So offset offset is used here. Offset 0 there. And then it gets incremented by that. Okay. All right. So for doing position, texture coordinates, and the bindings, okay. So position. It's giving me an error here. Oh, it's not the buffer, it's this. Got it. So attributes dot get 0 binding 0 location 0 format is that. Format R32, G32, B32. Okay. G32, B32, S float. So 32 bits per color, I guess. What's this say in there? And offset is 0. So offset is, this will do int offset equals position components times VK utils float size. Okay. So int offset equals position components times is it float size? Float length. It should be 4, right? Yep. And then we're doing attributes. Oh, it's doing attributes again. Okay. Sure. Attributes. Get 1. That. Binding 0. Location is 1. Format is RNG 32. S float. It's offset. Okay. We have int stride equals offset plus texture coordinate components times float size. Okay. And that is the bindings. Get 0. Binding is 0. Stride is stride. 0. Stride is stride. And then what's the other one? Input rate. VK vertex, input rate vertex. VK 14, VK vertex, input rate vertex. There we go. And then we're creating this thing with the bindings and the attributes. All right, so then info. What are we doing? S type default vertex binding descriptions. Attribute descriptions. All right, and then I'll just return components, and it's going to be attributes, bindings, info. And public static. Void clean components, and then we just do components dot attributes dot free components dot bindings dot free components dot info free. Right? Okay. Good. That's maybe not necessarily any more illuminating than what was there, but it makes me feel better. So we're back to then create pipeline, and then here, what are they doing? Go all the way back. All right, they're grabbing that, and then they're creating the pipeline build info. Right, pipeline build info. Okay, so we got the CM buffer. And pipeline build info. And we need what? Shader modules. Text input state create info. Right. So shader program that gets shader modules, and then vertex buffer dot info. And that is apparently not correct. Expected 3 arguments, I found 2. Oh, I need color format. Okay. Oh, we're doing get surface format, get image format. What the frig? Image format. Source format, image format. Get surface format. Surface format. Do I should have that here. Where the hell they have that at? Get surface. Have the scene. Get surface. Surface is one of their classes. Do I have a surface class? I should. I have Vulcan surface. Vulcan surface. Where is that? Vulcan renderer. Vulcan renderer has it. Do I have anything in? So I pass scene into Vault Forward Renderer, which is where I think we're at right now. Maybe. Yeah. Where is scene used though? Oh, I just set it to there. Yeah, so I need that. I need surface. guess I'll just add surface to here. The only usage of this anyway. So I need to pass that into here. So what are they doing? Surface gets surface format, image format. I assume that that is the image format. No. Oh wait, no, this takes... Oh yeah, it takes color format. Okay, I'm going to assume that that's correct. I'm not quite sure here. Info. And then we're doing the depth format. To depth format. Okay. Depth format is DK14 dot. What do they have here? DK format D16. K format D. There it is. 124. 124. All right. Set push constant ranges. So what's he doing? Okay. So it's a list of these two things. Push constant range. DK shader stage vertex bits. Vertex bits 0 and then matrix 4x4 size. Go. Shader stage fragment bits. Matrix 4x4 size is the offset. And then it's int size. Okay, so we got those in there. And then scripter set layouts. That is... Oh, that's passed in. Descriptor set layouts is passed in. Oh, forgot that. Actually, do I need to even pass that in? Because it's going to be set to... What do they set it to? Oh, they create a new descriptor layout. Uniform, fragment storage, and that. Okay. So I do need to pass that in. Layouts. Right, and what else do they have? And then they create the pipeline with the build info. Call cleanup. Alright, so create a new pipeline, right? Yes. Okay. Pipeline. Cache and info. Right, and then we're calling cleanup and then returning that. So buffer util clean text buffer and return pipeline. Right, so then up here, just say create pipeline with the pipeline cache surface and just do that for a second. And get rid of pipeline create info. I see they called pipeline info cleanup in there too. Okay. So it wasn't completely far-fetched. A lot of it was just renamed and moved around, it looks like. Okay. So then the create pipeline here. I'm gonna do these descriptor layout stuff. Descriptor set layout, descriptor set layout, descriptor set layout. Texture sampler info. Alright. Alright, I can feel my brain starting to shut down here. So what I'm gonna do is say, what can we do here? Let's say to do create set layouts yes to each. Let's make a note here for myself. Get back in line with is from chapter from new chapter forward. Finish descriptors in for renderer. And that's really it so far. Final plumbing for chapter 8. Okay, so we have that. There's a lot of stuff just hanging around here. So I am gonna go just commit all of this right now, whether it compiles or not. Great starting. Trying to rebase on new changes to chapter 5 forward. More to do. Okay, that's out there right now. Yeah, I'm gonna stop here for tonight for the coding stuff. I'm gonna take a little bit of a break. I'm gonna go offline for a little bit, take a little bit of a break. I might be back around another hour or so, hour and a half. I'll be back, and I'm gonna take a look at the playtest for a game called The Lift. See if it's something in my wheelhouse or not. We'll see. Yeah, we'll kind of go from there and see what we got. I don't know if I'm gonna play that all night, or I might switch it up and play a little bit of that, and maybe we also have Deep Rock Galactic Survivors is out, fully released now too. And I was playing a little bit of that off camera. Also, Jump Space has come out into early access. So we played the demo of that before, and that's kind of out and doing stuff. So I've been doing a little bit of that. Also, on top of that, I noticed that one of my favorite kind of side games, Puzzle Quest, just had, I don't know when this released, but there's Puzzle Quest Immortal something, Immortality Edition or whatever, which revamps, I guess, the visuals and stuff of the original Puzzle Quest, and I think it has like parts of 2 and 3 in it too. I don't know how it. I'm not quite sure, but I've been playing through that off camera as well a little bit. That's a little bit harder of a game to stream because there's not a whole lot to see. But it's yeah, because it's a match 3 thing. But I might even drop into that too. We'll see. We'll just see what's happening there with all that. And then tomorrow I'm going to try to start up earlier at nighttime and get to, try to do like a long stream like I did last Sunday. And we're going to start up Expedition 4 Redux in No Man's Sky. So, which Expedition 4 was the space worms. And I remember, I think I played a little bit of that back when it was first came out, but I didn't get very far in it. So it'll be nice to revisit it and also be able to like pull all that stuff forward into my main save and all that stuff. So cool things there. So that's what's on tap right now. So like I said, I'll be back in just over an hour probably, and just take it from there, playing some games. So thank you so much everyone for watching. If you happen to run across this on the YouTubes and you have a like and or subscribe that you can spare, maybe drop my way, that would be really swell and awesome. Otherwise, thank you so much for watching, everybody. I hope everyone has an excellent morning, afternoon, or evening, depending on what it is for you. Hope to see you back here again in the future for some more stuff, whatever happens to suit your fancy. Until then, see you, bye.
Phrasing?